In this video, we'll continue working on page number 8 on handout. And let's see, number 4. Number 4 is written in radian mode. So we need to come up with the idea how we separate 5, 12 as number we already memorized using special right angles. So we have 2 pi and 3 pi together makes 5 pi. And 2 twelfths will be 1/6 and 3 twelfths will be 1/4. So we reduced. Since these are special right angles, special angles from the right triangles, and we can use the memorization, okay? So co-co-sa-sa, that is the formula. Since this is sum, we have minus in the middle, and we don't switch the order of the angle. So pi over 6, pi over 4, pi over 6, pi over 4. Pi over 6 is 30 degrees. So cosine 30 degrees is root 3 over 2. Cosine pi over 4 is cosine 45 degrees, root 2 over 2. Minus 1/2 times root 2 over 2. So answer will be root 6 minus root 2 all over 4. Okay. Next question, number 5. This problem is written very kindly because every angles are in the first quadrant. So we don't need to worry about sign, okay? Everything is positive. Make sense? All right, so let's try to draw it instead of using Pythagorean identity. Either way works, okay? But we will use our drawing today. All right, let's see. This is a right triangle, and let's say this is angle A. From geometry, right triangle trigonometry, opposite over hypotenuse is sine ratio. So what is the other leg of this triangle? 5, 12, 13, right? I memorized this, so I don't need to worry about calculations. 5, 12, 13, Pythagorean triple. And we get answer quickly. Okay, next one, let's draw another triangle. The drawing is not accurate, okay? It's not scaled at all, but I need to draw a right triangle. Cosine B, so I'm going to label this angle as B. And cosine is adjacent over hypotenuse, so 3, 5 here. So what would be unknown? 4, 3, 4, 5, that is Pythagorean triple also. So you have integer values you can use, and this will be much simpler in calculation. So let's start with the difference of sign identity. Sine, cosine, sine, cosine. Angle A, angle B, angle B, angle A, ABBA. And in the middle, we keep the same sign. So let's plug all the numbers we have. 5/13 is given from the problem. And 3/5 is also given in the problem. All right, so subtract sine B. Sine B is not given here, so we need to find out from the work, okay? So this is opposite side from angle B, so that is 4/5. And cosine A is from here, 12 over 13. And then we can simplify all. So 5 times 13, 65 in the denominator. On the numerator, 15 minus 48. So we'll calculate it. What do we get? Is that 33 over 65 with negative sign? So that's how we simplify, okay? Number 6. Once again, it's same thing, right? So let's see. Cosine A plus B will be written as sa. AB, we don't switch it. But we switch plus minus sign in the middle. Do I have cosine A? Yes, it is given in the problem. Do I have cosine B? Yes, it is in the problem. Do I know sine A? No. I need to find it. Do I know sine B? No. So I need to find it, okay? So we can think about sine A squared plus cosine A squared. Cosine squared of A equals to 1. You plug 1, and then you can find the other one, okay? It's Pythagorean identity. It is from Pythagorean theorem, so instead of doing that, since AB are first quadrants, I don't need to worry about plus minus signs. So I will use drawing, okay? Let's say this is angle A. Cosine is given. Cosine is adjacent over hypotenuse. Can I find this height, which is opposite side? So let's calculate. 13 times 13, 169, right? Subtract 9 times 9, 81. What is the difference? 88. Is that a perfect square number? No. So let's simplify. What number does it go? 8 times 11? 8 is 222, right? So that has 2 as a paired number and 22 inside. So 2 square root of 22 is the simplest form of root 88. Okay? So we have root 88 as on opposite side. So from here, what is sine A? 2 root 22 over 13. Now let's do sine B. Sine B is from this condition. So let me draw same type of the drawing. And opposite side, we don't know. Adjacent is 1, hypotenuse is 5. So let's calculate opposite side from Pythagorean theorem. Okay? So 5 times 5, 25. Subtract 1. And then take square root on it. That is root 24. What is simplest form of root 24? That is 4 times 6, isn't it? So that will be 2 root 6. Root 4 is a radical number with perfect square number, so that is 2 root 6. So knowing that, let's find sine B. Sine B is 2 root 6 all over 5. So we need to find not given information using Pythagorean identity or Pythagorean theorem. And then let's simplify all together, okay? So denominator is 65 as same, both of them. And on the numerator, we have 9 times 1, 9, minus next to 1, we have 2 times 2, 4. And square root of a lot, right? So let's see. Square root of 22 times square root of 6. So I will factor it out. 11 times 2 times 2 times 3. So this one has another pair, 2. So instead of writing 4, let me write 4 times 2 makes 8. And inside of the square root, we have 11 times 3, which is 33. So that will be the final answer. That is the exact value. How do you feel? Too much with the radicals, right? So we need to practice simplifying radicals. Next question, number 7, simplify. So let's think about how to do this problem with pi and theta, okay? So can we use some identity? Sure, psi, co again. And then pi and theta, theta and pi. So we switch angles, ABBA, plus sign in the middle. What is sine pi? All right, here's the graph of sine going up and down, back to 0. And this is 2 pi, here pi, right? What is the location? Okay, it's on the midline, isn't it? So that's 0. So this is 0. 0 times cosine theta. The whole thing is 0, isn't it? Right. Next one, sine theta times what is cosine pi? Do you remember cosine pi? Start from the peak, going back, and then come back here. So sine pi was -1. So what do we get from this? This will be whole thing is 0, right? That's 0. So this will be negative sine theta. Negative sine theta. Next one, cosine theta plus theta. So we are trying to drive the formula for double angle identity. So if I simplify this, that can be written as cosine 2 theta. So we have talked about this before, and let's use Coco Sasa for the formula, okay? Coco Sasa. There is no AB. everything is theta. So we put theta in the middle. Instead of plus sign, we put negative sign by the formula, okay? So let's simplify. Cosine theta repeat twice. So that's square of that. And same thing here, sine squared over theta. So this is the first type of the cosine double angle identity. Okay? All right.